Hello, and welcome back. This is my implementation of a feature from the game Dishonored 2, launched in 2016, where you play as a supernatural assassin. So essentially a first-person stealth game with some cool abilities. One of those abilities is time travel, where you can view and travel between two versions of a level. And we're going to emulate this effect by doing just that, making a copy of the level, where objects and NPCs can be placed separately in either version. And a special thanks to all my supporters. Thank you for helping me help others. This is a fresh first-person blueprint project, and all I've done is added a time travel folder and imported a PNG into it. So we're going to start by making a copy of most of the level's objects. Of note here is you have this selected item. It's at 1745 and 600. So if I hit Control D, it makes a copy. It's now at 1755 and 610. So it's been moved 10 in both X and Y. 10 is not a magic number. I'm going to undo that. It is based on the grid snap up here. So if I set this to 5K, and then I hit Control D, it's now 5K, moved in both directions. So we'll use that to make our level. So in our outliner here, we can grab a folder. If we duplicate that, it duplicates the folder with nothing in it. It's not very handy. If we duplicate the folder and its contents, it makes a copy of the folder and the contents, and that looks fine. However, if you were to try and drag that entirety into another folder, you see that the structure is gone. So while Unreal does a great job most of the time, this is a case where it does not shine. And in your project, you may want to create some editor utility functionality to smooth out this kind of process. Instead, I'm going to undo that. I'm just going to basically select everything up to here, and then also select the playground. And we're leaving out the lighting and the simulation cubes, which is these blue things. That looks good. Hit Control D on that, and there's our copy. So effectively what we're doing is that this one copy is the current time, and then the other copy is the future or the past, or however you want to do it. So to do that, we're first going to create a render texture. I'm going to call this RT underscore time travel. Once that's done, you can right click it, hit create material, call this MAT or underscore time travel. So right clicking and doing that, all it's really doing is adding a texture component and setting it to the base color. However, we want our material domain to be user interface. And we're also going to apply a mask, so we can then just set this to masked. And then we have to hook up the RGB to the final color again. And I'm going to hold T and click. We're going to want a second texture sample in here. And for this second texture, all we're doing is using our time travel mask I imported. See, it's a big image with a block that's white. And with that done, we can close the material. And we also want to create a widget blueprint. We'll name this a WBP underscore time travel. You may be sensing a theme. And here all we're doing is we're adding a canvas panel and then an image in it. And the image we just want to hold Shift and Control and click down here, and it takes up the full screen. For the image, we can open up Brush. In here, we'll select our Render Textures material. And I'm going to set this to Save on Compile Always, because I like to be able to do that in one click instead of two. So then to be able to see this, we need to add something to our first person blueprint. The first person character blueprint in this template project does not have a BeginPlay. You can just add BeginPlay here, or you can hit override in the function section and find BeginPlay. It'll pop it down to the bottom here. So in BeginPlay, we just want to create a widget. This will be the time travel widget. And then for this widget, we're just going to drag it out and add to viewport. So if we just run that, you can see it pops up. It has that mask section that's just black. So in here, we're going to want to add a spring arm. You leave it as the default name, and under the spring arm, we want a scene capture component 2D. For the scene capture component, we just want to make sure that the texture target is set to our render texture. And if we were to leave that all as is and go in and hit play, you'd see that it's being updated, but there's a few issues. So some of those issues are in the spring arm, we want to make sure that our target arm length is actually 0. And we want it to be basically viewing the world the same as the first-person camera. If you click on the first-person camera, you can see that it has a location that's a little different. And here we can copy this, paste it into our spring arm. We don't need a collision check. And if we run that, it'll look a little better. However, you can see that it's following the one rotation, but not the other two. Well, the other one, we're actually using yaw. So in that case, we want to use pawn controller rotation. And now it can go up and down as well. So there's a few things of note. First, and very obviously, is that the widget image looks really bad. This is because the render target's default is just a size of 256 by 256. We can easily change that. And let's do that first before I talk about the other bit. So in our render texture here, we have our size, X and Y. Let's just set this to 1080p. And now that looks a lot better. However, you can see that the scaling is different. This does not match that or anything else very well. And that is effectively due to the aspect ratio. So if we were to stop that, we go in here and we launch a new editor window instead. You can see that it's matching now very well. So that's effectively because we want our render texture and the game running at the same aspect ratio. When we launched as a pie window here, you can go into advanced settings. You'll see in here that it was running at 1280 by 720, which is a 16 by 9 aspect ratio, just like the 1080p. So the problem here is that we have our render texture, it's set to a static value, but players will generally set the resolution how they want, and it may be a different aspect ratio. The difference between 16:9 and 16:10 might not matter much, but an ultra widescreen resolution will make it much more noticeable. So there's at least 3 ways to get around that issue, all of which are out of scope for this video. The first is that you could have a render target asset created for each aspect ratio, and then you'd have to pick it dynamically depending on the resolution that's been set. But if you're picking it dynamically already, you could just create a render target dynamically and set it in the scene component and the widget's material. And lastly, you could just add some other effects around the widget or inside the material to make it not matter as much. The other aspect we have in here is that you can see that the scene capture is much darker. This is likely to do with where in the process it's capturing the scene. There may be a better way to match it, but what's more likely to happen is that you'll want the current and other versions to differ anyways. You could drop the global lighting way down and add a bunch of lighting to one of the areas and not the other. You could also change the way the time travel material is processing the render target. So with that done, we can then do the other part. So our spring arm here, we basically just want to set our target offset to 5K, 5K, and when we run that, it's now pointing at the other version. So you can see that in one version, we can see these blue cubes, in the other we can't. So you can differ the way objects look in either location, have objects added in one and not the other, and vice versa. And then, of course, you can also have NPCs patrolling in one area and not the other, which is how the Dishonored 2 worked. And in that case, the NPCs wouldn't detect the player unless the player's actual character was there. But then how do we transition between the two versions? Well, on our first person character, we can add a tab event. Just choosing tab because I like it. And in here, we want to create a new variable. We'll just call this is time traveling. And control drag that out. Drag that out, hit B. In both cases, we just want to set it to the opposite value. So if it's true, we set it to false. If it's false, we set it to true. We then need to update our spring arm. And that was the target offset that we're using. So in the case where it's false, we're just setting this back to what we had initially, which is 5,000. If you're physically at the other location, then that means the target is then negative 5,000. And then we also want to set this actor's location to the other side. And that location is based on the actor location currently. And we're just adding a vector value, which is effectively the opposite that we're using here. So in this case, it's negative 5,000. And in this case, it's positive 5,000. So now when we run this, we can see the cubes over here. If we hit tab, we're now on the other side. We can only see the cube through the viewport instead. And what if we want to have a little bit of fun with that? The way this first person template works is if you pick up this gun, you can shoot at some balls. When the balls hit these cubes, they are physics objects, so they'll go flying. Actually, without anything, we can just show that. And they go flying. So where that's happening is we go in our first person blueprints folder again. We have the first person projectile. In here, there's an event hit, which is adding an impulse to the object. So we're just going to then add a function here. We can call this swap actor timeline. And that's going to take in an actor. Let's call it other. And here we have a sequence. We're just going to get our player pawn, cast that to the first person character. Grab our is time traveling and branch based off that. I'm just going to create a local variable, call this offset, make this a vector, and then we're just setting that value. Set this to negative 5,000. And lastly, the sequence here, all it's doing is we're taking our other and calling set actor location. Which is based off this actor's current location plus the offset. Now you may want to set this to teleport. And then in our event graph, we can just drag the swap actor timeline into right here. Just pop that up there. And the actor is the other right here. Now the only other thing of note here is that we're using the actor location of the projectile to add the impulse. We'll see what that looks like. So when we shoot, add this, it's gone flying into the other side. A little hard to see because there it goes. You can see it's spinning a lot and whatnot. So the reason that is because again, this is like that. If we then set the actor location of the impulse based on this, it's not 100% correct here. We'd actually want to take the actor location of the projectile and apply the same translation to it as we have in our swap function, but for now this is fine. And now it won't shoot quite so ridiculously strong. Now it's kind of barely moving, but a little better. Thanks for watching. If you liked the video and would like to see more, you know what to do. And if you would like to support this channel, watch these videos 2 weeks early, or just want to download the project files, you can do so through my Patreon linked below.